Good morning, everyone. My name is Haider Witwit. I'm one of the solutions architects on AWS side who are dedicated to the VMware Cloud and AWS offering. In today's session, we're going to talk about the options to build integration between your workloads running on VMware on AWS on one side, and on the other side, your workloads running on native AWS services. These integration options we are discussed today are the results of the joint offering and engineering between the VMware and AWS teams to give you these options when you wanted to architect your solutions on AWS platforms. The key in these integrations are the way that you privately communicate between two platforms, using the best of the technologies on each side in a way that you can enrich your options when you build your applications on AWS Cloud. Level set for expectations is that this is going to be a deep kind of technical session. That's kind of 200 plus if we have that option. So expectations from my side is that you guys need to be familiar with some of the basic AWS concept, like what's AWS VPC is, what is like load balancers, application load balancers that we provide with our platform. That's from the AWS side. My expectations as well is that most of you guys are familiar with VMware platform as well. So you know what an ESXi server is, you know what vCenter does, you know this stuff with vSphere. So at the end of this session, I want you guys to walk out with a few things. Primarily for the ones who are not familiar with what VMware on AWS is, we're going to provide a quick overview. I know a lot of sessions have done that before. I apologize if there will be kind of a repetition for some of the slides that you have seen before, but this is just to kind of get up to speed with the primary building blocks. And then we're gonna dive deep into these integration options. At the end, I know a lot of people, probably of you guys, have been hearing about now you can do vMotion for your machines from on-premises to the cloud. So let's just try this one out and see if it actually works. So we actually have a lab environment that we have set up, and at the end of the session, we will try to live vMotion a machine to the cloud. Starting with the overview for VMware on AWS, when we had conversations with our customers who want to adopt the hybrid model, really the results of these conversations is that customers want to have the flexibility to have the option to choose where to put their workloads. They don't like the binary decision of you either put your stuff on premises or you put them in the cloud. They want the flexibility of, I have some workloads that I would put on premises using VMware platform, and I also want to be able to kind of put some workloads in the cloud, and I want to have like rich integration between these two platforms. And the best of that is that I want to do that with no hardware purchase. They want to get off the hardware purchase business. However, when those customers kind of wanted to adopt that model, there have been challenges. And these challenges are around you dealing with two different platforms, which means that you have to do everything twice. When you work with VMware, you have your VMware templates and images that you have to maintain. When you work with AWS, you have the Amazon machine armies that you have to maintain. You have different networking capabilities between the different platforms. True, it's L3 connectivity. I can build VPNs and et cetera. But you still, when you design your workloads, you have to design based on the requirement of the platform. Operation inconsistencies. Of course, your runbooks, your processes, your what to do when certain things happen will change. Will have to vary based on the platform or where do you plan to put this workload. And of course, from a learning perspective, our customers have significant investment in educating and kind of building the skill sets of their admins and staffs when they're working with vSphere or VMware. But that doesn't mean that they can do stuff on AWS and vice versa. So there is this kind of different skill set that's required between the two different platforms. Monitoring and tooling and access methods all really kind of varies between the different platforms. So as a result, we said, why don't we just give you the option? Let's just bring the leader in private cloud and private computing, VMware, with all of their capabilities around security and networking and storage, and put it on the most reliable and leader platform of the cloud with AWS. Utilize the networking capabilities, the global reach, the on-demand model with purchase, where you only pay for the stuff that you use, and then you can basically turn them off after that and release them, and you don't have a commitment, you're not purchasing hardware, you don't have to plan for capital expenses. So this model will enable a lot of use cases that was really challenging before. For example, now migration is super easy. Now we're talking about, like imagine, have you ever really thought at one point that you'll be able to do a vMotion for your machine while it's serving data with minimum to no network disruption from the on-premises to the cloud, which is something we're going to try today. So that's one example. You have all of the scenarios where you want to close down a data center or consolidate data centers. You can really do that in a remarkable time that was super challenging before. The extension where you want to build a presence for your application in a region that could be really anywhere. And in the past, you used to need to go and kind of get the space and hardware and people and manage that site. Well, right now, it's as easy as launching cluster in one of the regions that support the service. And we keep adding more support for regions. And the plan is to get to a point where wherever we have a region, you have the capability to launch a VMware cluster there. Disaster recovery. I mean, and each one of you who had to kind of provide a DR for their site know that I'm building a site that I'm not going to use. And eventually, I have to pay for all of the engineering. But still, my hope is that I'm not going to kind of flip over or build the mechanism that's going to flip over. And in this model, I mean, if you can really do that and with minimum to no kind of capital expenses or paying for stuff that you're not using, that's really going to be fantastic. And at the end, really, we're touching a new point here where because you're dealing with these two different integrated options, you get the features of the two platforms. So now when you design your applications, you're not really kind of limited with one platform can do for you. It is a distributed application that you can utilize the capabilities of both platforms. So let's get into the overview of that VMware cluster that runs in the cloud. From a building blocks, these are all technologies that you know. It comes in the unit of software-defined data center. That software-defined data center is built out of vSphere, the vSphere that you know today on premises that's managed by the vCenter that you're familiar with. This is from a computer perspective. The storage will be provided by vSAN, and the networking tier and security capabilities are provided by the NSX, the network distributed platform. All this runs on AWS infrastructure. The goal here is that you will build integration or have the integration with your on-premises resources. Since vSphere 6.5, VMware started to support the hybrid link mode. What that means is that you have a single pane of management where you can log into one vCenter and manage multiple vCenters. And with manage multiple vCenters, it's as easy as I'm taking a VM from one cluster that runs on-prem, put it on cluster that runs in the cloud, or vice versa. You have the flexibility to choose where the transfer goes. So this is supported with VMware on AWS. And the goal also is that the same tools from automation perspective with vRealize and PowerCLIs will support both platforms. Add to that there is a rich integration here with AWS services. Remember, this VMware cluster runs on AWS infrastructure, which means that you have this low latency, high throughput connection to all of the services that operate on our platform. And in addition to that, we have added a special engineering where we enable private connectivity as well, which is what we're going to kind of dig deeper during the session today. Learning more about the software-defined data center, the hardware, the bare metal is provided by AWS. These are bare metal EC2 instances that we provided to VMware. They put the ESXi software on the top of it. It has an equivalent resources to the i3-16X large EC2 instances, which means that you get dual 63 cores CPUs. So you have 72 virtual CPUs, 5 terabyte half terabytes of memory, 15 terabytes of all NVMe SDDC drives. This is the storage tier that vSAN is going to utilize to build a distributed storage across the nodes, the 4 nodes of the cluster. Remember that you don't really get the fully 15 terabytes. You get about 10.6 terabytes per host. This is due to the kind of the operations of vSAN to build that storage tier. And with every host, all of this information is per host. And with every host, you get 25 gig elastic network interface. Hypervisor is ESXi, sits directly on the physical host. It's maintained by VMware, which means that you don't have to worry about the maintenance, the upgrades, the operations, where you spend a lot of time today to go to do these maintenance stuff. This is all managed by VMware for you. But because this is managed by VMware, you're not going to have a root access to the hypervisor. So you'll get a delegated access to do the operations that you need to launch VMs, to edit these VMs, to provide connectivity, but not really to worry about that level of management on the host level. Storage provided by vSAN. vSAN will be the storage solution that will utilize all of the hosts for all of the nodes in the cluster and give you the capability to create storage policies per VM to say this is the failure to tolerance setting for this virtual machine. Depends on the kind of data you put in it. Today, there is no direct support where you can use EBS or EFS directly to the host level because you don't have really kind of that access to the host. What you can do, however, is that you can map EFS to the VM level itself, not to the host. NSX, as I mentioned, will be the networking platform that will build the virtual networking that will enable you to do the addressing for your VMs, the connectivity between the VMs, create logical networks, create IPsec tunnels, firewall policies, NAT capabilities. All that is managed by NSX. Although the ESXi is the underlay, basically this level of networking you're not going to see on the VPC level or on the AWS level. You will only see what you need from a VMware perspective for the virtual machines that you provision. vSphere, all of that is within the kind of the vSphere package managed by VMware. You get delegated permissions, and you can create hybrid link mode to enable to manage not just this cluster, but also your on-premises vSphere environments. To be able to get into the integration story, we want to know how the virtual networking and some of the underlay networking works here. So that VMware cluster really runs in a dedicated VPC. This VPC is going to be per cluster. The cluster sizes start with as small as 4 and can scale up to 32 today, with plans to increase that. These hosts are bare metal, as I said. VMware will put ESXi on the top of that directly. And the networking between these nodes is the EC2 networking. So that's the VM kernel networking for host management, for vMotion, all really managed by VMware. You're not going to get access to that. What you can do, however, is to build the overlay networks. There is one default overlay network provisioned by VMware, which is called the appliance subnet. This appliance subnet is for the management appliances, like vCenter and NSX managers. Those are appliances that you can access directly. You will get an endpoint. But the level of networking for that appliance is managed by VMware. So you can configure the gateway, which is the management gateway here, to control what IP addresses can access the vCenter, if you want to create a tunnel to this tier, if you want to basically provision public IP addresses. That's all kind of stuff you can do from the console or CLI. But the actual appliance is managed by VMware. You're not going to get root access to that appliance. The virtual networks that you can configure are the ones that you use for your workloads. So now I want to create a VM. I'll start to create virtual networks. So in the case of, let's say you have a distributed tier, three-tier application, database, web tier, and app tier, now you can start to create these logical networks. These logical networks, the connectivity between logical networks and two logical networks from other remote networks are managed by a separate gateway, which is the compute gateway. Both of these gateways are NSX edge devices. Still managed by VMware, but you can access them to configure the firewall rules and NAT capabilities and IPsec tunnels. When you create a VMware cluster, the SDDC cluster, SDDC, by the way, is short for Software-Defined Data Centers, you have to specify a VPC, a normal AWS VPC that you own and manage. This can be an existing one that you have, or could be a new one that you will create. During the process, there will be a network interface created for you in the subnet that you choose, utilizing an IP address from within that space. The purpose of this interface is to enable connectivity between your normal workloads inside this VPC, EC2 machines, RDS instances, Redshift databases, and your VMware workloads. So that's why you see the association for the ANI goes to the compute gateway. That's because the compute gateway is the router, is the edge device that manages connectivity to your workloads. And that's why with this network interface that lives in your VPC, you get the high throughput, low latency connection. This is 25 gig network interface where you can build distributed applications. Let's say I have an application that's utilizing SQL today. I'm managing it today, but I've heard about this great capabilities of RDS that I want to use it. This is straightforward. You can basically have your front ends living in VMware and your backup, your database, utilizing one of the RDS engines. We're going to talk about that in a bit more details later during the session today. So looking at the picture that we just had, when we imagine the account structure, there will be two primary AWS accounts involved for every VMware deployment on AWS. There is the AWS account that VMware will provision for you. It's dedicated for you, and they will launch your cluster inside a VPC in that account. So this is a dedicated account for you. VMware manages the account. They give you the information for the account. They tell you this is the account number that we're using for you. Reason is because sometimes you want to build integration with services like Direct Connect when you can share a virtual interface with AWS account. So you need to know what is the account number they're using for you. But you're not going to access to the console or get permissions to that account. The other account is the normal AWS account you know and use every day. This is where you will provide a VPC where VMware will create the endpoints for the VMware cluster. You will be responsible for the bill. You'll get a normal bill that you know for the AWS account that you own and manage, and you will get the bill for the other account where VMware launched your cluster from VMware directly. There have to be some cross-level permissions, of course, because if you think about it, VMware is going to create an interface in my account. That means that they need to have a permission in my account. So there will be an IAM role that you will configure in your account and give some permissions to the VMware side to say, create this ANI in my account. And also there are some operations that require some updates that will also needed in that role. The role is really the kind of permissions is documented at the website. You'll see what kind of permissions they can use with your account. We'll have a better understanding like what permissions they will need to do and why during the session today. So now let's talk about the connectivity. The first connectivity model we want to touch on is my VMware SDDC to my AWS account. This is what we showed earlier, but focus on on the connectivity from the private part, utilizing the route table. I said ANI, and I was referring to one ANI. However, there are multiple ANIs that will be provisioned in your account. But only one of them is active because only the host where the CGW, the compute gateway, which is a virtual machine, VMware virtual machine, runs, will actually be active because that's where it's connected to your VPC environment. The connectivity, in this case, will have to be enabled or provided through the route table, the normal VPC route table. So for your VPC workloads, the way they communicate to remote networks, they need to have this remote network in the route table, which is what that IAM role is going to enable VMware to do, to go and update your route table to say, hey, those are my logical networks on VMware side, put them in your route table, and put that ANI as the gateway to get to them. However, we all know that VMs and hosts can fail. Let's say hosts can fail in this case. What happens if in the unlikely situations where host 1 failed? VMware, as part of the managed service, will automatically vMotion the compute gateway to a different host and do all of the necessary updates on your route table to say, now you need to change that network interface to point to the new one since your compute gateway lives in a new host now. Everything is taken care of for you. You don't have to worry about anything. This is part of the permissions that VMware need to have in your account to be able to update your route table. Of course, updating route table also comes when a new virtual network is created or deleted on the VMware side. You don't want to go and worry about that by yourself. Everything is taken care of. The way VMware do that is really by triggering Lambda functions to go and make these updates based on triggers on their side. The other connectivity model is on-premises, VMware cluster on AWS and your on-premises environment. This model works with Data Connect. Of course, it works also over public internet, but there's no fun in that. Let's talk about Data Connect. Data Connect is the service that will enable you to have a dedicated connection to AWS. The service by design supports multi-accounts, meaning I can create a Data Connect connection and share it with a different AWS account. In this case, remember, VMware owns an account for you. So when you create this connection, you need to go and say, I'm creating this virtual interface for this account. You create that, you share it with them, and you go to the VMware console, the VMC console, the VMware Cloud and AWS console, and just accept that connection. So if you're familiar with AWS Data Connect, there are two flavors of the virtual interfaces. There is one called private virtual interface. The goal of that interface to enable connectivity to AWS VPC, like the private space within that VPC. That's the private VIF. We call it short by VIF. The other one is the public virtual interface that enables connectivity to public endpoints. So touching on the first one, the private VIF, remember, your VMware cluster runs in a VPC. You want to be able to connect to that VPC. So you just simply create a private VIF. VMware will associate that. They will create the VGW, the virtual private gateway. You don't get to see that. They will associate it with the VPC. You only check a box, say, yes, I accept the data transfer charges for that Data Connect. You don't have to worry about anything else. Interesting, though, is today, it's a partial support for Data Connect. So private virtual interface only communicate with a VPC range, but it's not going to help you to communicate with the overlay networks that you create, the logical networks. This is something in the work to enhance, but for today's support, your private VIF will give you access to the VM kernel, like the vMotion and host management. And if you want to enable access to your workloads VMs, you'll have to create tunnels. And these tunnels will go, depends on what resource you want to access. If you want to access the workloads VMs, you create a tunnel to the compute gateway. If you want to access like vCenter behind a VPN, you create a VPN to the management gateway. Interesting part here is that both compute gateway and management gateway use public IP addresses. So in this case, going back to the public virtual interface is an interface designed to enable connectivity to public IP addresses within the AWS address space. And so since those are actually running within the AWS address space, these two public IP addresses will be advertised as part of the public range we advertise to your site over public VIF. So in brief, you can create these tunnels over AWS backbone instead of internet. You can still connect them over internet, but when you do it over AWS backbone with Data Connect, that means you get the advanced performance because you get low latency, really low jitter, low latency, low jitter, high throughput. If you want to enable connectivity to your normal VPC, you'll simply create a private VIF to your VPC to enable that connectivity. It's not going to work by connecting to the SDDC cluster and then get to your VPC from there. So now we get to the part of building the integration with native AWS services. When we talk about AWS services, we focus here on the services that can be accessed from your VPC, meaning you using a private IP address to access an AWS service. Because if we talk about the public address, you can access that from anywhere. Although you get the enhanced performance because you operate within the same backbone when you do that from the VMware cluster. But the goal is here, I want to use private addresses addressing to communicate with these services. So that's why we'll talk about the AWS services that can be accessed privately from your VPC. And there are three groups of services that can do that. The first one is the VPC gateway endpoints. And these gateway endpoints are services that can create an endpoint or gateway inside your VPC where you go and update your route table and use this route table. And this route table will basically route your traffic to the service instead of routing it through the public internet or the public AWS network over the public IP addresses. The goal here is that I'm not adding an IGW or an internet gateway to my VPC. I'm actually using all the address space, private address space to access these services. So two examples for gateway endpoints. We have two services today that support that, S3 and DynamoDB. S3 with VMware and AWS can be accessed with two options. Option one is that your compute gateway can utilize the IGW that's associated to the VMware VPC, and you will simply access the service directly from there. The other option that's really configurable, you can choose that from the console. Say you can say if I want to access S3, I want to access over a private endpoint that I have in my VPC. In this case, the network ranges for the S3 service will be advertised to the route table of your SDDC, and all traffic that's hitting S3 will be routed to that ANI in your VPC and utilize an endpoint that you own. Benefit here is that you can write down advanced bucket policies where you say, this bucket, for example, can only be accessed from this endpoint from my VPC. In this case, traffic coming from your VMware environment is not going to look as a public traffic. It's going to actually look as private traffic coming from your VPC. The other example for endpoints are endpoint services that use a private address in your space, in your VPC space. These endpoints, we call interface endpoints, are supported or powered by PrivateLink. PrivateLink is a new technique that we announced, I think, last year. And it's basically use a model, an interesting model where you have a separate VPC that provide a certain service. So in this case, look at the VPC on the left. That's an AWS VPC where there is a service to be provided, to be consumed by different AWS users. This service really can be anything at this point, as long as it's a TCP service. It will run behind a network load balancer. That's a standard layer 4 TCP load balancer. So the service nodes will sit behind the load balancer, and the load balancer will have an ENI, a network interface that will live in the consumer VPC, using an address space from the consumer VPC, so that when the consumer wants to access this service, it will just send the request to that private IP address, and it will be routed in the backbone to the service. What does that mean? When you have VMware on AWS, you simply can launch your ENI, VMware ENI, in that same customer VPC, and you can access that service also privately. So the service here will present a DNS name that need to be resolved by the AWS resolver to give you the private IP address. So recommendations here is to enable the name resolution to work to the right IP address, is to do some proxying for DNS requests from your customer VPC. One of the things that you can do is launch the AWS directory service. It's a managed AD service where you can have a DNS. DNS will be part of the AD server. You will simply point that or use that private IP address as your DNS serving the VMware VMs. In this case, all requests to access the service will be resolved by this DNS to the right IP address. So this is how it works. But what kind of services I can access with this model? There are three groups of services that can be accessed with PrivateLink. First, AWS Services, native AWS services. We have a long list of services, and we keep working on adding more to these to this list. All of these AWS services can be accessed privately by addressing that IP address in your VPC with a PrivateLink. Other type is services offered by other AWS accounts. So you can, as an AWS user, you can create a service, use the service, put it behind a network load balancer, and enable the power link, the private link for the service, and offer this service to anyone on AWS. And there is a model to kind of how you can control access to the service. The third part is Marketplace products. Marketplace products, actually SaaS products, started to support this model and give you the possibility as a user to consume a service from Marketplace privately without accessing a public endpoint. Let's touch on some of the examples. Systems Manager is a managed service from AWS that will allow you to do really plenty of things. These are a group of capabilities all baked into one service that can enable you to do plenty of operations management from the service itself. And the great thing about this is that it supports both EC2 and on-premises VMs in the past. And at the past, when we said on-premises, we were talking about like, this is a VM, that's an agent-based service. You can install it on, as long as the OS is supported, you can basically put it on Windows or Linux OS, and then this operating system will communicate to the public endpoint in the cloud. The difference here is that when we're going back to this model, now that VPC on the left is the VPC for the service. We have the EC2 Systems Manager. The VPC is managed by AWS. You as a consumer, you create a private endpoint for EC2 Systems Manager. You get a private IP address within your VPC. And your agents, when you install your agents will simply talk to that private IP address and start to send the metadata that will enable you to do the different operations on your EC2 VMs and extend that to the VMware VMs. So now, in the past, that traffic needed to go over public internet or direct connect. Now it's all within your solution, and it's all addressing private IP address. Another example, I said also service providers can be you. You are an AWS account owner. You can create a service, and you can basically share the service of a private link. The way it works is that this is your account, that VPC on the left. You create an NLB, Network Load Balancer for the application, and then create an endpoint, private link endpoint. Step number 3 is you specify who have permissions to create this endpoint. Those are IAM users or principals. And once you create that, this IAM principal can go and create the endpoint, and eventually, last step, you can activate the connection either manually or automatically based on who requested or who provisioned the endpoint. The third group is services that are available in the marketplace. SaaS, those are SaaS services available in the marketplace that are PowerLink, private link enabled. We have an example for some of the services here. Those are services from Aqua and from Cisco, primarily security, network monitoring, data analytics. So these are stuff that now you can really utilize from not just your EC2 instances privately, but also from your VMware VMs running in the VMware on AWS. The last group of services is services that create an ENI in your account, very similar to how VMware on AWS create an ENI in your account. Great example, our RDS, Redshift. Those are services. When you create an RDS instance, we don't really launch an EC2 machine and put RDS within your VPC. We actually do that in a VPC that we manage and create a network interface in your account where you see a private IP address that you know. And when you send, and that will be your kind of the IP address for your endpoint. And when you send traffic to that interface, we actually route it in the backend to our EC2 in our VPC. So in this case, RDS is really straightforward. When you want to access RDS, it's just a matter of routing. As long as the compute gateway have the route to send that traffic to the ANI, which is managed for you, your traffic will access RDS directly. Another example for this model is Worspaces. Worspaces is our VDI solution where when you create an Amazon workspace, there are 2 interfaces for this workspace. There's one for the PC over IP connection, which is your management traffic, your session with the VM and or the workspace. The workspace have another interface, which is ETH1. ETH1 interface is for data. When you create a workspace, you choose where you launch that ETH1 interface. In this case, since you choose where you launch this ETH1 interface, it can simply live within the same customer VPC that you have your VMware endpoints. And that means that you can access all your workloads inside the VMware cluster from your workspaces without traversing the internet, without needing to create any tunnels or anything else. To extend this connectivity, you can also have private virtual interfaces or VPNs over direct connect to your on-premises, since usually you want to access your data, and your data can live in the VMware cluster on AWS, can live on premises. You have the flexibility to kind of manage this solution. The last option I'm going to touch on is something more general. It's not really specific to endpoints. This is about a capability with application load balancer. Application load balancer started to support something we call API-based targets. In the past, application load balancer only supported backends to be EC2 instances. However, we added support where the backend can be a private IP address within a scope that you can access. And by definition, that can be VMware on AWS, which means that you can launch an application load balancer, configure your backends to be VMware machines running in that cluster, and you get the high throughput, the low connectivity. And because you can do that, that means that all capabilities within ALB can be used to load balance traffic to your VMs. And not just that, ALB actually comes with a lot of features. For example, you can use our web application firewall to protect, to do the level 7 protection on the application level for your applications running in the VMware environment. Shield is our DDoS mitigation service, works with ALB. Now you get your DDoS mitigation taken care of. Route 53 can simply integrate with ALB to do the name resolution and CNAMEs. That's all taken care of for you. Content delivery. CloudFront can simply integrate with ALB as the origin and help you with all of the capabilities for the distributed and additional application filtering on the edge. So all of these things are available now because you have this private connectivity. That's why at the beginning of this session, I focused on the part that I have the private connectivity that I need to treat this as a local environment. When you build things today, usually within your environment, you are limited within what you have available in your private space. Now with AWS and VMware on AWS, you have plenty of capabilities all within your private IP space that enable you to do these things, all routed and managed by AWS. So I promised you to try out something today. I think I have enough time to try that. So I'll start this one out and then talk about the setup in more details. Can you switch? Sorry, it seems we're running into some technical challenges. Do I need to do it from my side? So to give you some information about the setup that we have a lab environment in one of our Huntington offices where we have an on-premises VMware environment. We have a direct connect between this on-premises VMware environment and a cluster, one of the VMware on AWS clusters in US East 1 region. The physical distance between the two sites is about 20 miles. So you don't really know for sure which data center your stuff in when you put in stuff on AWS. This is part of the security model. But we know what our physical data center is for the on-premises. So once we switch to the to my machine, I plan to log into vCenter, which is configured with the hybrid link mode, and then take a machine that's running from on-premises and do the vMotion that you know. However, usually when you do vMotion on-premises, you do it between different nodes in the same cluster. The difference today is that we're going to move it from one cluster that runs on premises to the VMware cluster in the cloud. During this operation, we plan to do a continuous ping for the machine for the purpose of seeing like what is the network performance looks like during this migration. VMware vMotion usually comes at promises where there is a minimum to no network disruption. We can try that out. I know that used to work pretty nice with within the same cluster when you have everything connected to the same switch. However, now that we run it over different sites, and specifically a cloud being a destination, it can, it's not that easy to do that. The primary piece that enables this is Direct Connect. VMware have some networking requirements for vMotion to work. Okay, that's promising. So VMware have some networking requirements for vMotion to work across sites. These requirements are about the latency and the minimum bandwidth, the persistence bandwidth. Latency in VMware documentation is you need to maintain no more than 150 millisecond latency for the round trip. And you need to provide persistence at least 350 megs of bandwidth. These are things that you can easily provide with Direct Connect. However, the challenge is when you do that over internet, you are really governed by the internet weathers. So because of that, you'll find VMware find it hard to support vMotion operations over internet. So that's why when you want to enable vMotion today with VMware on AWS, you need to have a Direct Connect in place. The Direct Connect, really there are 3 requirements to enable Direct Connect to meet the vMotion direct requirements to VMware on AWS. The first one is you need to provide the connectivity to the underlay network, which is the VMware kernel on premises with the VMware kernel in the cloud. This is primarily, if you've done this before, the vMotion network on the one side need to be able to talk to the vMotion network on the second side. The second requirement is you need the 2 vCenters to talk to each other. And the third requirement is you need to do the L2 extension. L2 extension, the purpose of that, this is an L2 VPN connection, by the way, between 2 NSX edge devices. The purpose of that is you are maintaining the IP address of the machine during migration. So the thing is, if you're doing migration to a different network that utilizes a different IP address, I'm definitely going to go through a network outage because that IP address is not consumable on the destination network. That's why you need to do this L2 extension where both of these networks utilize the same IP space so that the same IP address will be maintained with the machine during migration. I don't know if we'll be able to do the demo today. I apologize for the technical difficulties. Yes. We can take questions as we're waiting for the screen mirroring. If you have any questions, happy to take them. Do you want to? Oh, no?
If you have questions, you can raise your hand and come to you.
Okay.
Yeah, on your slide, you said EC2 bare metal. So is that simply an AMI that's customized to run VMware?
Yes. This is an AMI, Amazon Machine Image, that's built by VMware with all of the necessary drivers to run directly on the bare metal EC2 instance provided by AWS.
Okay.
That was close. I really apologize for the technical details. I was hoping to do the vMotion today.
Excuse me. Over here. Can you repeat what you said? I didn't hear a word you said about the bare metal piece.
Oh, I'm sorry. The question was about Is it a developed AMI by Amazon Machine Image by VMware to enable it to run directly on EC2 bare metal? The answer was yes. VMware worked on this AMI, developed the necessary drivers to be able to run on EC2 bare metal.
Okay, are you working with anybody else to do similar things?
So not to the best of my knowledge. Right now, this is with VMware only. I'm not aware of plans to do that with someone else.
Thank you.
Thank you.
I have a quick question for you.
Okay.
This may be off topic, but how would this integrate with the vRealize stack for on-prem?
So the vRealize is one of the new features that was enabled with the releases, the VMware releases during the Frankfurt Summit last week. So now you can run vRealize Suite. I'm sorry, I apologize. Is it vRealize or Horizon?
vRealize.
I'm sorry,
yeah.
I apologize, my bad. The vRealize is fully supported with VMware and AWS. You can use the same vRealize scripts and automation techniques that you use today for on-premises for the deployments on the VMware and AWS.
So if I had vRealize Operations Manager on-prem, I can connect to AWS
Yes.
Cloud? Okay.
Yes, yes.
Thank you.
Welcome.
Any other questions?
Okay, well, thanks everyone. I apologize again for the technical details. Wish you found this session informative. Please provide your feedback in the mobile app. We're really interested to hear how we did and how we can do better next year. Thank you very much.
Thank you. We're taking a brief break. The next session starts at 11 a.m. and it's migrating Oracle to Aurora utilizing AWS Database Migration Service, a customer journey.
Where would they be transferable or?
Yes, so it's not,